We have studied about the importance of the composition of soil, the volume composition of soil, and the important roles. And also, I think I have told you about soil colloids. What is a soil colloid? What is a colloidal state? What is a crystalloid? And already I've sent you some notes also. You might have gone through that. So properties of soil colloids also I have sent. So let's see individual what each property means and how it gets involved in the soil chemistry. So we know that colloid has two phases, I told you, dispersed phase, dispersed medium, and the size of the particle is very less, that is about less than 0.001 mm, means it's a very small particle. So the different properties which are exhibited by soil colloids are adsorption, then Brownian moment, electrical charge, flocculation, cohesion adhesion, swelling shrinkage, then plasticity. So what do you mean by each term? You need to know the difference between adsorption and absorption. See, AD and AB. You know what is absorption. So entry of any substance into another substance is absorption. Surface absorption, only surface it gets absorbed, means that is adsorption. So adsorption is defined as the surface absorption, and it is very large when there is more amount of colloidal particles present in any medium, because the colloidal particle size is very small. It will have a very large surface area, means more ions will get adsorbed on that surface. And again, it depends upon, the adsorption depends upon the nature of ion, the type of colloidal particles, means the valency of the cation. See, each cation has different valency. Okay. Each ion has a different valency. For example, hydrogen 1, we say silicon has 4, oxygen has 2. So like that, valencies are different. So it depends upon the valencies of ions you get adsorbed on the clay complex. So higher the valence of cations, more strongly it gets absorbed on the clay complex. Hydrogen ions, H+ ions, behave as polyvalent ions, and it gets adsorbed on the surfaces of colloids more strongly. That is when water is added, it has H+ ions. So that H+ ions will get adsorbed on the surface strongly compared to the divalent cations such as Ca2+, Mg2+. So in different clays, there are different clays. I told you 1:1 type of clay and 2:1 type of clay. 1:1 type of clay example is kyanite. 2:1 type of clay mineral is montmorillonite. So in general, the ion exchanges, when it takes place, example, phosphorus is an anion. Phosphorus ion, H3PO4- ion, gets adsorbed more in montmorillonite clay, means 2:1 type of clay compared to kyanite clay. So that is adsorption. So adsorption depends upon different valency of the ions. It may be cations, anions. So, and it depends upon the surface area also. So that is adsorption. Brownian movement. See, colloid particles also move. When we add soil into this water, the soil particles start moving in a zigzag manner. They will not, when you add soil to the water, it will not directly go and fall into the water and reach the surface base of the any vessel. It will move in a zigzag manner. So colloid particles are found to be continuously in motion, and they colloid with each other in the liquid medium, and they tend to coagulate, means they tend to come together, coagulate, and that is called as flocculation also. And this is seen when clay and humus is present in the soil. That is, Brownian movement is zigzag movement of any soil particle in the medium is Brownian movement. So clay will have this property of motion of particles in any media. Next property is electrical charge. So I said clay is the only particle responsible for chemical reactions to take place because it has a charged surface area that is negatively charged. So colloidal particles have an electrical charge. Some colloidal particles are positively charged and some are negatively charged. When clay colloids are suspended in water, it will carry a negative charge. Therefore, it attracts the positively charged ions that are cations. So most of the nutrients taken up by the plant, like cations, are calcium, magnesium, sodium, H plus ions, Al3 plus ions, all these are cations. So it gets absorbed easily on the clay surface because opposite charges attract each other. They get absorbed on the surface of the clay because of the electrical charge. Next, what do you mean by flocculation? Flocculation means coming together of the soil particles. They coagulate, they flocculate, and this happens when calcium ions are present in the soil. Opposite of this process is called as dispersion. The flocculated soil particles get dispersed, they get separated into individual particles, and that happens when sodium ion is present. Sodium causes dispersion. You should remember this. Sodium ion causes dispersion of soil particles, and calcium ion causes flocculation. In other words, this property of dispersion will destroy the soil structure. The ideal property required for a soil is flocculation. If soil should be flocculated so that aggregate formation is good. So flocculation. So the process of formation of flocks is called as flocculation. Clay is coagulated by the use of aluminum, calcium. This condition is beneficial to the crops because stable aggregates get formed in the presence of ions like Al3 plus, Ca2 plus, H plus, Mg2 plus, K plus, and sodium. Sodium, if it is more, means it will cause dispersion. So when we see the soils of different regions, like humid regions, subhumid regions, the colloidal complexes are dominated by aluminum and hydrogen and calcium. And these ions encourage flocculation and they consequently help in the formation of aggregates. So this is in humid and subhumid regions. You see flocculation taking place. Whereas in the arid regions, we observe sodium ions dominate the exchange complex. And this results in destruction of the soil structure because of dispersion of soil particles. So they create undesirable conditions or poor conditions for the soils where drainage is a problem. Sodium is present means it is very hard. So in arid regions, we find sodium predominating in some of the soils. So why flocculation is important in growing of crops? Flocculation is important in the role of agriculture because it improves the physical condition of the soil and it is beneficial for plant growth. So that is flocculation. You should know when we say define flocculation, you have to write that. Flocculation means coming together of soil particles together to form stable aggregates which are ideal for growth of plants. Next, coming to the property plasticity. We know clay is sticky. Clay you can mold clay into any shapes. Therefore, soils having more than 15% of colloidal clay exhibit plasticity. Plasticity is defined as the ability of the clay to be molded into any shape. That is plasticity, and it is very important because it encourages the change in soil structure, and this is more related to the tillage operation. See, when we plow the soil, we try to break the soil structure. The beds will be very big, clods will be there. So when we plow the soil will tend to form aggregation because of the presence of clay particles which exhibit plasticity. Then cohesion and adhesion. So this plasticity, whatever property, cohesion, plasticity, flocculation, there should be attraction of soil particles along with the water, or soil to soil, water to water. So cohesion means attraction of similar particles with each other is referred to as cohesion by cohesive force. Adhesion means attraction of soil particles which are different, means soil and water. So the solid and the liquid. So they are referred to as adhesion or adhesive forces. So both these cohesive and adhesive forces develop in the presence of water, and these two forces help in the retention of water in the soil as well as absorption to the plants and microorganisms. So this property is important, which is exhibited by the clay particles, that is colloid. So what next property is, what happens if we remove water from this clay? Clay will become dry, it will shrink. And when we add water, it swells. So the property is swelling and shrinkage. Next property of clay colloid is swelling and shrinkage. See what happens when you add water to the soil, it contracts, or means it expands. So expand and contraction will take place in the soil. So contraction and expansion in volume of soil with variation in the moisture will influence various properties of the soil, and this happens because of the presence of clay colloid. So shrinkage occurs in dry conditions when water is removed and causes a decrease in volume. So due to this both shrinkage and swelling, we find cracks in the soils. You would have observed black soils in cotton's growing areas, black cotton soils. You will find a picture of a soil with cracks, severe cracks. That is because of the presence of clay and due to the property of shrinkage and swelling. And where it is found more, this property means a soil having more amount of 2:1 type of clay, that is montmorillonite, which is expanding. Montmorillonite is also referred to as expanding type of clay, that is 2:1 type of clay compared to 1:1 type of clay, that is kyanite clay. So they have these expansion and contraction, then presence of montmorillonite helps in the formation of a good soil structure. The next property of clay colloids is non-permeability. See, colloids, I said there are two phases. They will not form a true solution. They are unable to pass through a semi-permeable membrane. Means this membrane will allow passing water and other dissolved substances, but retain the soil colloidal materials. That is why we say clay exhibits, soil colloids exhibits non-permeability. So these are the properties of soil colloids. So these are the 8 properties. So some more properties, flocculation over, Brownian movement. Any other property which is left out? Yes, see, soil colloids less than 2 micrometer in diameter size. Surface, again, I'm going to just sum up the properties of soil colloids. Surface area is high, and therefore they can absorb more ions, and more ion exchange mechanisms can take place if the surface area is more. When the soil particle size is very small, the electrical charge or the surface charge of the clay is negative. Therefore, it can attract the cations, the positive charges, onto the surface of the colloid, and later it releases for uptake of nutrients by the crops. Then it experiences adhesion, that is attraction of soil particles to water, means water retention occurs in the soil because of this adhesion cohesion properties. Then clay exhibits swelling and shrinkage properties, that is clays will shrink when soil is dry, and it will swell when it is wet. And the phenomenon observed here is contraction and expansion of the volume of the soil. Then dispersion and flocculation, you should know what is dispersion and what is flocculation. They are opposite to each other. Dispersion means splitting up of the soil particles into individual particles by the presence of sodium ion, whereas flocculation is forming aggregates or coming together of soil particles because of presence of calcium ions. Then clay will experience even Brownian movement, that is zigzag movement of the clay particles in any medium is Brownian movement. Then one more property, Tyndall effect, it also scatters the light. Then plasticity, that is ability of the soil to be molded into any shape, which is important in tillage operations. So these terms you should know. And so they will ask you to write short notes on nature and properties of soil colloids. Means you have to write all these 12 properties and explain each one of them. Understood so far?
Yes.
Okay, fine. So next, coming to, I told you about 2:1, 1:1 type of clay. What does it mean? There are different types of silicate clays. So next, coming to the concept of silicate clays. See, clay means it is made up of hydrogen aluminum silicate. HAlSiO3 H is hydrogen, Al is aluminum, Si is silica, O is oxygen. So any clay will have hydrogen, aluminum, silica layer. So that is silicate clay. It is tetrahedral in shape or octahedral in shape. So I'll tell you what is a tetrahedra, what is a octahedra, and what is size of the silicate clays. Like how soil colloids, similarly silicate clays, when we analyze clay, it will have silica, alumina, iron, and chemically combined water. So these make up 90 to 98% of the colloidal clay. And this colloidal matter also contains plant nutrients like, see, when we analyze soil, it will have nutrients. So it will contain calcium, magnesium, potassium. So we say clay is a mixture of hydrated alumino-ferrosilicates. Definition of silicate clays: it is a mixture of hydrated alumino-ferrosilicates of varying composition, mixed in some cases with an excess of silica or sesqui oxides, SCSQI oxides, that is R2O3 general formula. Sesqui oxides means iron oxides and aluminium oxides are called as sesqui oxides. So the term clay in general has three meanings. So you might have studied in your fundamentals of soil course that the size of the clay is less than 2 microns in diameter. That is called as clay. Secondly, we also have the textural class: sandy soils, clay soils, silty soils. So clay is also referred to as a textural class. And third one, it is a name for minerals of specific composition. So clay means three meanings it has. So many materials of the clay, already I told you, like sometimes gypsum, carbonates, quartz, though they are small, they are not called as clay, and they are not based on the basis of size. Sometimes clay minerals will have size of 4 or 5 microns, double the upper size, the limit of clay size fraction. Clay means less than 2 microns. So what is the shape of the clay next? Silicate minerals. How do we study the shape of the clay? We have to, it is not visible to the naked eye, the shape or the size. So it has to be viewed through electron microscope. So they are, when we see the clay particles under the microscope, they appear layer-wise, lamina or leaf-like shaped. So they are laminated, we say. They are layers. Clay is made up of layers of plates. Plates, when you place one plate on the other, or flakes, or so they look like layers, or sometimes they look like rods also. So the different unit of flakes of clay minerals held together with different degree of force depends upon the nature of the clay mineral. So one layer placed over the other mineral. The edges of these clay particles are cleanly cut and others are fluffy, and others are, means they puff up, fluffy. So in some cases, clay minerals are developed more because we say it is layer-wide, horizontal axis. It will have a horizontal axis. So the horizontal axis will be more compared to the vertical axis. That is why layer by layer we refer to as shape of clay. They are layered silicates, we say. See, silicate clays are layered silicates having iron, silica tetra, silica layer and aluminium layer, we say. So that is the shape of the clay. Next, coming to surface area. Clays are having high surface area because of, silicate clays are having high surface area because of the smaller size. Some clays will have two surfaces, one internal surface area and the other one is external surface area. The internal surface area exists between the area of the particle that allows the absorption of molecules when the clay is present in an aqueous solution. all clay particles expose a large external surface area. So when two layers are placed like this, one above the other, internal surface area will allow absorption of water. When we see the above surface area, it will be more. So external surface area and internal surface area. So what is the role of the surface area of the silicate clays? They can be used for absorbing various types of substances, and they are measured, and the surface area of some of the clays examples are, you should remember this one. So Montmorillonite, to Montmorillonite. This is 2:1 type of clay, expanding type of clay. It has high surface area, about 700 to 800 square meters per gram, 700 to 800. Coming to Kylanite clay, 1:1 type of clay. It has 5 to 100 square meters per gram. You have to remember these two because it will occur in your exam. Surface area of monolite is 700 to 800 meters square per gram. Kylanite is 5 to 5-100 meters squared per gram. Some of the other clays have high surface area. Examples are vermiculite, mica. You might have seen vermiculite or mica. They are mixed layer clays. They have surface area of 300 to 500 square meters per gram. Then some of the other micaceous clay have surface area about 100 to 300 square meter per gram. Amorphous clays, they have 100 to 500 meters square per gram. So you should remember surface area of these different clays. Then silicate clays, they also, like soil colloidal property, they have an electronegative charge, which already I have told you. And this is because of the presence of the negative charge ion, and that each cell is referred to as a clay micelle. Clay, MICELLES, that is microcells. This clay carries negative charge, and a number of oppositely charged ions are attracted to each colloidal clay crystal. So these colloidal clay particles have inner ionic layer and the outer ionic layer. Inner ionic layer is strongly, the edges will have negative charge, and the outer ionic layer will be surrounded by cations. So that is the electronegative. Adsorbed cations. So clay missiles, we say the clay cells, micelles adsorb number of cations like H+, Al+, CHO+, Mg2+, Na+, K+. So amount of these cations varies with a different type of clays. So these cations adsorbed on the clay determine the physical and chemical properties of the soil, therefore influences the plant growth. Example, alkali soil, we say problematic soils, acidic soil, saline soil, alkali soils. Acidic soils means H+ ions will be absorbed more. H+ and aluminum ions will be more in acidic soils. Saline soils means calcium ion, magnesium ion, sodium ion will be there. Alkali soil, more sodium ion will be, number of more sodium ions will be absorbed more in alkali soils. So that is the importance of electronegative charge. So you know what are silicate clays? Silicate clays are clays having layers of hydrogen, aluminum, silica layers. Coming to the type of soil colloids. Next, colloid, you know what is colloid? Different type of colloid, you should know. And what is the definition of micelle? MICELLE, that is microcell in the clay. the individual crystalline particle is called as micelle. What is a micelle means? The individual crystalline particle is called as micelle, and these colloidal particles are considered as occupying intermediate position, being neither lyophilic nor hydrophilic. That is, we have two types of colloids. Some absorb water, some do not absorb water. So we say water-loving colloids and water-hating colloids. Lyophilic colloids, lyophobic colloids. So there are two types of colloids. Lyophobic colloids, lyophilic colloids. Phobic means you have a phobia. They repel the water. They do not absorb the water. Philic means they absorb the water. So clay colloid possesses the properties of hydrophilic because of its hydration, and its sensitivity to electrolytes is a hydrophobic nature. So coming to what are lyophobic colloids. In lyophobic colloids, the surface tension means when any substance absorbs water, it will have a tension with which it is held. Only if there is tension, water will be held. If no tension means water will freely move out. Only if surface tension is there, it will hold the water. So surface tension and viscosity of this colloidal system is similar to the dispersion medium. Means small quantities of electrolytes present in the solution causes precipitation. So these particles are easily detected in the ultramicroscope, and we can see that they migrate in one direction in the electric field. So when this is observed on the microscope, the solution having the clay particles, we can see some of the ions get precipitated and moves in the different electrical field. That is lyophobic colloid, means water-hating colloids. Lyophilic colloids. The surface tension is usually lower and viscosity is much higher than that of the dispersion medium here. Large quantities of electrolytes cause precipitation, and these particles cannot be easily detected in the ultramicroscope, and they migrate in different directions and not all in an electric field. So this is lyophilic colloid. So among all kinds of soil colloids, example, silicate clays are most dominant, and they should be philic. They should absorb water now for those whatever fertilizer or manure we add. All those nutrients should come into solution, means it should absorb water. So our colloid should be lyophilic. So the silicate clays are most dominant and imported in the field of agriculture. Except sand fraction, all soils contain particles of colloidal size. So soil colloids are chemically active portion of the soil, and they determine the physical and chemical properties of the soil. So they are broadly, again, so colloids are classified into two based on absorption of water, into lyophobic colloids, lyophilic colloids. The next classification of colloid is organic colloid, inorganic colloid. Organic colloid is humus, inorganic colloid is clay. So the difference between these two you should know. Inorganic colloid means clay minerals, hydrous oxides usually make up the bulk of the soil colloids. Here, the size of the particles are less than 0.001 mm in size, and the clay fraction includes particles less than 0.002 mm. Therefore, all clay minerals are not strictly colloidal. So that is inorganic colloid. Organic colloid, they include humus, that is the decomposed end product of organic matter decomposition forms humus, that is the organic colloid. They are more reactive chemically, and they have a greater influence on soil properties per unit weight of the soil than the inorganic colloid. So humus has an important role compared to clay. Humus is amorphous, powder form, and it is chemical and physical characteristics also varies because it is dynamic in nature, it keeps changing. So based on the organic content, organic colloid, inorganic. So you should know types of soil colloids classification. One is lyophilic, one is lyophobic based on the water loving or water hating concept. Second, based on the organic matter content, that is organic colloid, inorganic colloid. And the next one, clay minerals are usually crystalline, although some are amorphous. Amorphous means powder, crystalline means crystal-like structure, and they have different chemical configuration. Crystals means like sugar crystals, salt crystals. The arrangement of atoms will be different or configuration is different. That is why the crystalline nature also occurs. Both inorganic and organic colloids are intimately mixed with other soil solids. Therefore, the bulk of the soil, the whole soil, are essentially inert, and the majority of the soil's physical and chemical characteristics differ depending on the type of colloids present in the soil. So that is the classification of types of soil colloids. Coming to the examples, crystalline silicates, types of soil colloids. Examples I'm giving you. Crystalline silicates. Under that, we have 1:1 type of clay, 2:1 type of clay. 1:1 type of clay will have one layer of silica layer and one layer of aluminum layer attached to each other. That is 1:1. Non-expanding type of clay. Expanding type of clay, 2:1 montmorillonite. It will have one silicon layer and two aluminum layer. One silicon layer middle, two aluminum layer. That is octahedral structure. That is 2:1. Expanding type of clay. That is crystalline silicates. Non-crystalline silicates means examples, allophane, 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 and one more is volcanic ash. You would have seen ash, that is amorphous in nature, that is referred to as immogolite, IMMOGOLITE. Then we have another type of soil colloids, iron and aluminum oxides, hydroxides, oxyhydroxides. Example are geotite, you would have seen in your soil mineralogy course. Geotite, gypsite, hematite, magmite, ferrihydrite. And the another last colloid is organic matter, humus. High and low molecular weight acids, humic acid, fulvic acid. So these are the types of soil colloid. So this much is clear, right? You know what is colloid, what is the properties, then what are the clays, then types of classification of colloids based on water loving, organic matter, crystalline, non-crystalline. This is much is clear. This is clear now?
Yes, ma'am.
Okay. So for today's class, this much is enough. For next class, I will explain to you the structure of layer silicates. So tetrahedral structure, octahedral structure, those drawings. So I will send that first to you. You can go through that and then I will explain to you. Okay. So you take that, you have taken the screenshot?
Yes, ma'am.
Okay, nange kalsri adu. So next class ali how a clay structure means how clays are made, silica tetrahedron, aluminum octahedron. So our structures ella tilkoಬೇಕಾಗುತ್ತೆ, how they are arranged and the drawings ಇದೆ. tetrahedron ante central and silica irutte. It's surrounded by 4 oxygen atoms. So all those drawings you need to know. So I will send in advance that material for you so that it will be easy for you to understand the structures. Okay, right?
Okay, ma'am.
Okay, fine. So yeah, I will end the class. Any doubts, you can always ask me.
Thank you, ma'am.
Okay, fine. Yeah.